Hello, everybody. Welcome back. Second week of technology evaluation presentations today. I don't think I have too much administrative stuff. The demo and the written part of the technology evaluation are due, I believe, at the end of next week. So, hopefully you're working on those. Of course, there's technology evaluation summaries, very short, summary of the videos that we're seeing here. Learn the lesson that your classmates are trying to tell you, and I guess write a couple of points or paragraphs or something to convince me of that. Otherwise, I enjoyed last week's videos. I haven't, as I record this, watched this week's yet, but I have faith. Otherwise, let's go. I'll say hello again after the break.
Hi, this is Group 6, and today we'll be presenting our tech eval framework, Angler. I'll start off by giving a quick summary of Angler, and Melanie will then follow off with an introduction to TypeScript. Harry will then speak about the use cases as well as the pros and cons, and then Erica, Lewis, and Jimmy will then be showing some cool features of Angler and demoing them in our code demo that we made for this presentation. And without further ado, what is Angler? Angler is an open source web app framework developed by Google in 2016. And some of you guys may have heard of Angular.js, which actually came before the Angler we know today. And it actually came in 2010, 6 years before Google actually came up with TypeScript Angler. Again, this is an open source framework for building scalable cross-platform client applications, so for either web or native mobile and desktop environments, and people tend to choose Angler for its speed, performance, and code reusability. Regular Angler uses TypeScript, which transcompiles into JS. Angler is Google's top choice for building their web applications, so it pretty much supports most or all of their services. So Gmail, Google Meets, Maps, and so forth. Other companies that use Angler include PayPal, the Weather Network, Wall Street Journal, Forbes, Overleaf, and so on. So this graph here was taken from the Stack Overflow 2020 survey. And as you can see here, Angler is ranked number 3 in framework popularity. And in the contrary, Angular.js is ranked second to last. From the same survey, Angler is not popular in the computer and technology sector, but it is a good choice for creating general purpose web applications. As you can see here, 83% in the other category. In terms of full stack frameworks, Angler is part of the modern mean stack, whereas the typical mean stack uses Angular.js, which is not what we're doing here. So in a nutshell, the mean stack comprises of MongoDB, which is a flavor of NoSQL databases, Express.js, the backend framework, Angler, frontend, and Node.js as the runtime environment. So to cap it all off, pick Angler when you want cross-platform integration on desktop, mobile, and for native and hybrid web development, especially for large-scale dynamic applications, since it breaks down complex architecture into maintainable components. Leading up to my next point, Angler is a great choice for building progressive web applications such as Discord, Uber, and Spotify, and it's even better for single-page applications. If you have a massive team of developers working on a single project, and they all happen to know TypeScript, then use Angler. Angler supports a vast amount of built-in libraries, and it even has its own command line interface tool.
Hi, I'm Melanie, and I'm going to be doing a quick introduction to TypeScript, the main language used for Angular. TypeScript is an open-source programming language designed and developed by Anders Hejlsberg at Microsoft in 2012. It is the main programming language for the framework Angular and can be used for both server-side and client-side. It is commonly used for large applications. TypeScript is supported in multiple IDEs such as Visual Studio Code and making it easily accessible. In 2019, TypeScript placed third in the developer survey on Stack Overflow due to its use in Angular and its compatibility with JavaScript libraries and frameworks. It can also be used with other JavaScript-related frameworks such as Vue and React to develop applications. Here are some main Java and TypeScript features. TypeScript is a superset of JavaScript, meaning that existing JavaScript programs are also valid TypeScript programs. TypeScript is a compiled language not interpreted like JavaScript, so it can't be run directly on the browser. Therefore, it needs to be transpiled to JavaScript first. To transpile code means to take source code in one language, in this case, TypeScript, and produce the same source code but in a different language. In this case, it would be JavaScript. The tool that does this is the TSC, the TypeScript compiler. TypeScript, in addition to everything available in JavaScript, also provides optional static typing, as well as things such as interfaces, enums, abstract classes, etc. One of the special types that TypeScript has is the union type, which allows developers to combine already existing types. By having optional typing, the code is easier to read, self-documents itself, and allows for better debugging and refactoring. However, not all parts of TypeScript need to be strictly typed, so it provides developers with the freedom to choose how strict they want to be with typing. TypeScript also allows for object-oriented programming with classes, interfaces, etc. Above is an example of a class called person with the method getFullName. This ability to do object-oriented programming makes TypeScript well-suited for large applications, providing flexibility, reusability of code, and easier debugging. TypeScript has one main advantage over JavaScript, and that it has more safety with type checking. Since TypeScript has the option to be statically typed, TypeScript can detect type-related bugs at compile time, which will result in better performance in the long run and less confusion, since it makes debugging a lot easier. Here is an example of the advantage of using TypeScript. On the left is a short snippet of TypeScript code, and on the right is a bit of JavaScript code. By strictly typing the parameters and return value for the function add, TypeScript can detect errors such as invalid argument types at compile time. Here are some reasons why you might not want to use TypeScript. One problem with TypeScript is that there is one extra step of transpiling, which isn't actually that big of an issue because it doesn't take that much time and is usually automated. Another problem is that if you want to switch from JavaScript to TypeScript, then developers will have to put extra time into learning TypeScript specific concepts, which will lower productivity for a while. And finally, TypeScript isn't truly statically typed since it is optional. This can possibly cause weird type conversions while transpiling to JavaScript.
The pros of Angular. Angular is no longer using MVC architecture. It is now using component-based architecture like React. Angular components can be thought of as small pieces of user interface, like sections of application. While each component is encapsulated with its functionality, there is a strict hierarchy of components in Angular. For example, in Angular 9, Google Maps and YouTube Player components were introduced. As shown in this page, components are dependent features of user interface with their own structures and APIs. They can be copied, reused, and easily tested. Also, one component can be updated without refreshing the whole page. While MVC separated functions into different levels, components have all those functions in same level, the view level. The advantages of this changing are quite obvious. First, increased reusability. Components of similar nature are well encapsulated, in other words, self-sufficient. Developers can reuse them across different parts of an application. Second, and makes the code more readable. Encapsulation also ensures that new developers can read code better and make productivity faster. Next, it brings more convenience into testing. The independent nature of components simplifies unit tests and quality assurance procedures. Last, it makes maintenance easier. Components that are easily decoupled from each other can be easily replaced with better implementations. Apart from the architecture change, another advantage of Angular is that it has a higher performance. Multiple factors can help in making your application faster. The main boost is ensured by hierarchical dependency and Angular universal support. For hierarchical dependency injection, Angular builds a hierarchical dependency tree where injectors are coordinated with components, and you can apply dependencies and services into a whole subset of components. The approach provides high-performance scores for Angular applications. For Angular universal support, it renders the view on the server instead of the client. The problem of single-page applications is that they are initially rendered on the user's browser. Well, it has some benefits. It also means the app loads slower. With Angular universal support, the server will pre-render the web page, while the browser will still loading in the background. On the top of that, it provides with search engine crawlers with a pre-rendered page instead of a page lacking some content. It helps with search engine optimization. And let's come to the cons of Angular. First, divided and churning community. This is most since AngularJS 1.x. Users are likely to churn and don't consider transitioning to modern Angular. As you remember, you can't direct update from AngularJS 1.0 to the recent version of it. And another one is merging legacy system from AngularJS to Angular requires time. Not only does it take time, you will have to review many tools, transition to a new language, and deal with a heavier application as you both have Angulars running.
Let's take a look at some cool features which will persuade you into making Angular the front-end framework for your next project. We start with the simple. Event binding is a feature that enables your code to listen and respond to user actions, like a mouse click. The Angular event binding syntax is easy and simple. You put the event target name with parentheses to the left of the equal sign and a template statement to the right. Advanced usage includes creating custom events with an event emitter. For example, we can define a click directive and then create an event emitter inside of it. This event emitter now can call its method emit, which passes any sort of data through it as a message. For example, some string that says, I don't know, dummy help info. So when you click this help button, you will see the prompt, dummy help info. Angular directives are pieces of code, like classes in object-oriented design, that change the appearance or behavior of DOM elements. They allow for dynamic behaviors dependent on the component states and complex computations based on variable inputs. While you can code your own directives, there are also built-in directives, such as ng4, which allows us to present lists and tables in our HTML templates, ngIf and ngSwitch, which display elements based on given Boolean conditions, and ngStyle, which helps set multiple inline styles at the same time based on the state of the component. Directive classes not only support dynamic display and complex behaviors of components, but also code and component reuse. Let's take a look at how these directives can be used in a website. With ng4, we can display the data on our web page in the form of a table. As the input list gets modified, and notice how I didn't even need to reload the page, ng4 we'll try to avoid constantly creating and destroying the DOM elements of the list, because it's an expensive operation. Existing DOM elements will be reused and overwritten with new values, which reduces the cost of change. We can see ng-switch being used here to allow users to toggle between editing and displaying the details of a profile. ng-style is used here to style the components by bolding and italicizing certain lines if the user edits the content. Another cool feature of Angular would be related to a component's lifecycle. What's that? Well, each component or directive instance has a lifecycle that starts when Angular instantiates the component class. This lifecycle consists of stages, which are associated with a lifecycle hook method, which is automatically defined by an interface and can be implemented to get components to behave a certain way when triggered by certain life stages. For example, if you implement this method ng-on-init in your component or directive class, Angular calls it shortly after initializing the data properties for that component or directive for the first time. Here, we have implemented several hook methods: ng-on-changes, ng-on-init, ng-doCheck, ng-after-content-init to display a message when they're called. Now on this hero detail page, as I click into it, we can see these messages show up as the site invokes onChange, onInit, doCheck, after-content-init, after-content, and after-content-check in that order. Another cool feature of Angular would be the implementation of the observer pattern, which is used frequently for event handling, asynchronous programming, and handling multiple values. Essentially, any component can be defined using the observable keyword, which will maintain some list of its subscribers or observers. Basically, whenever a component publishes information in some of its functions, it sends a message to its observers automatically. Observables are flexible in that the interface allows for components to send multiple values of any type: literals, messages, or events. Not to mention, the code is the same for both synchronous and asynchronous communication. This is very useful indeed. Let's take a look at an example. In our demo site, we are using an in-memory database which simulates a server for fetching remote data. So we're communicating with the simulated server using HTTP requests. In fact, the HTTP response returns an observable value, which is essentially delivers its information to different parts of the website, which have subscribed to the object that has been returned by the HTTP response. This observable feature allows for the asynchronous case where data might not be fetched from the server immediately. We also use observables here to implement a search function, where we are able to basically search through all the champions in the database. More on that later. The last cool feature I'd like to demonstrate would be data transformation pipes, which are commonly used. Angular provides built-in pipes for typical data transformations, such as for numbers, dates, and currency. We can see here in this edit form how we are able to display saved birth dates of champions in a certain manner. You can also implement and customize your own pipes. For example, here with the exchange rate pipe and the price with discount pipe. By default, pipes are executed only when they detect a pure change in the input value, which allows for improved performance. However, there are also asynchronous pipes, which we have used here with the hero search, to push what we've written into an observable stream, which does some computation and invokes a search method. Without this pipe, your component code would have to subscribe to the observable to consume its values, extract the resolved values, and expose them for binding, and then unsubscribe when the observable is destroyed in order to prevent memory leaks. Well, Asynchronous pipes saves you from needing to write all of that code in your component to maintain the subscriptions and keep on delivering values from the observables as they arrive. So to summarize, we've looked at how Angular features such as event binding, directives, lifecycle hook methods, observables, and pipes can be used to make your next website all the more spectacular.
All right, welcome. This is the Group 20 presentation for CMPT 470. Today we're going to introduce Java Spring. So let's get into it. What's Spring? In Java, Spring is an open source design level framework. It solves the loose coupling between the business logic layer and other layers. Therefore, it applies interface-oriented program ideas throughout the entire system application. Simply put, Spring is a layered Java full-stack, lightweight, open-source framework. In the book Expert 101 Java 2 Platform Enterprise Edition Design and Developments, edited by Ron Johnson in 2002, he questioned that status quos of the Java Enterprise Edition system frameworks as bloated, inefficient, and divorced from the realities, and actively thought to explore innovations ways. Later, he created Interface 21 framework, which is lightweight development frameworks that tries to break through the traditional developments of Java 2 Platform Enterprise Edition. The Spring framework is based on the Interface 21 framework. After redesigning and continuously enriching its connotations, the 1.0 official version was released on March 24, 2004. Spring has been feared since its birth, and the reason can be briefly summarized as the following. The first is secure. Spring provides an easy and secure way to handle forms, logins, and so. It has a proven track record of dealing with security issues quickly and responsibly. The Spring committers works with security professionals to patch and test any reported vulnerabilities. Third-party dependencies are also monitored closely, and the regular updates are issued to help keep data and applications as safe as possible. The second is flexible. Spring is flexible, and the comprehensive set of extensions and third-party libraries let developers build almost any applications imaginable. At its core, Spring Framework's inversion control and dependencies injections features provide the foundation for the wide-ranging set of features and functionality. Spring takes care of all of the dependencies you might want or need to build all your kind and apps, and it can help you whether you are building microservices for web or complex streaming data flows for the enterprise. It could be a nightmare when you have to build a complex web app using Java, but Spring handles all the wiring exceptionally well. Spring Boot combines necessities such as application context and auto-configures embedded web servers to make a microservice developers cinch. It transfers how you approach Java programming tasks, radically streamlining your experience. Lastly, Spring also performs well in performance. With Spring, you will notice faster startup, faster shutdown, and optimized execution by default. Increasingly, Spring projects also support the reactive program mode for even greater efficiency. Spring Boot helps developers build applications with ease. Its abundant web servers, auto-configuration, and Farjars help you get started quickly. And innovations like leaf reloads in Spring development tools means developers can iterate faster. Now, we have the basic knowledge of Spring. Next, let's move further into the details.
Now, let's talk about the special features of Java Spring, the inverse of control and aspect-oriented programming. The first one is inverse of control. The inverse of control is not a technique, it's more like a thought. It inverts the flow of control as compared to the traditional control flow. The traditional coding style cannot adapt to the change in user requirements, requiring the programmers to manually create new class to meet user needs. If we have a huge amount of code volume, then making change to meet user requirements will be super expensive, needs endless repetitive work. So the inverse of control was invented to solve this problem. In the past, we create a new object by calling a new statement, like here the new statement, but now we choose to use set injection. Then the program will create objects according to what user passed to it. In this way, the initiative of object creation will be inverted from programmers to users. That's the concept of IOC. In Java Spring, IOC is implemented by dependency injection, like we saw here. Dependency injection has three parts. The client class, the service class, and injector class. So what is dependency? The client class depends on the service class, and the service class provides object to client class. We say they are high coupling. This makes coding more complicated, so we want to decouple their dependency. This comes with the third class, the injector class, which refers to IOC containers in Java Spring. The injector class takes information from the service class and creates objects and inject it to the client class. The client class depends on the object injection of the injector class, and the service class depends on the object creation of the injector class. This is the dependency part. And the injector class inject informations to REST classes is the injection part. In Java Spring, there are two dependency injection methods, which are refers to the setter dependency injection and the constructor dependency injection. Like we saw here, this part is the setter injection. It's a set method and the constructor injection. Nowadays, this architecture is used everywhere in our lives. Whenever a program can let user choose the theme or model they like, that should be an IOC architecture. There are three advantages of this architecture. It can decoupling the execution of a task from its implementation and making it easier to switch between different implementations and have more focus on business implementation. So now let's talk about the second special feature, the aspect-oriented programming. This is a programming paradigm that aims to increase modularity by allowing the separation of cross-cutting concerns. It does this by adding additional behaviors to existing code without modifying the code itself. This is done by inserting several aspects to the code through advice to join points, which satisfy some point cuts, like we show here. The join points could be refers to the object we create in our code. The point cut refers to some conditions that can be satisfied by parts of object. And the advice could be refers to the perform on the join points that satisfy some point cuts. And join points, point cuts, and advice are combined to be called an aspect. This makes sure that we can add new method or functions to the current code without changing any original code. But it only has one disadvantage, that object and aspects are in one-to-one relations. Developers should write new aspects for each object when new methods are needed. This comes with double code implementation.
Next part is about what makes Spring cool. We found two cool things in Java Spring. Firstly, Spring has an MVC framework called Spring MVC. In addition, Spring has Pojo implementation. Now, let's talk about Spring MVC first. Spring MVC is a Java framework that is used to build web applications. It follows the model view controller design pattern. just briefly introduce what MVC is. MVC divides a project into 3 parts, including views, controllers, and models. The model defines the application business layer. The controller manages the flow of the application. And the view defines the application's presentation layer. The separation makes multiple views able to share the same model. It improved code reusability. Since the 3 parts of the MVC model are independent, changing one will not affect the other 2. What's the difference between them? How does Spring MVC help Java web development? Spring MVC is also an MVC framework. The main difference between them is Spring MVC extends the MVC framework to include more layers. We can see the 2 images below. We can see Spring MVC contains a firm controller, which the base MVC doesn't contain. In base MVC, we have multiple controllers. These controllers are simple Java classes. Different controllers handle the different requests. We have to use some hard code to establish the mapping. It increases our workload. In Spring MVC, all controllers are annotated with 2 pieces of information, a URL and an HTTP method. How does the firm controller work? When a user's request comes in, it is accepted by the firm controller. This acts as the main controller and passes the request to the relevant controller based on the request mappings and HTTP method. Because all the controllers are annotated with a URL and HTTP method, the firm controller can map the URL and the HTTP of the request to the relevant controller. And then a particular method will be executed. Now, we come to the second cool thing, POJO. Spring Framework has POJO implementation. What is POJO? POJO means plain old Java object. It has 3 rules. First, can't instance anything. Second, can't implement anything. Third, no outside annotations. It just means a simple class without extra stuff that can be used by itself. All classes in the model layer has to be POJO classes. So, our domain logic code generally has no dependency on the framework itself. Since all logic codes has no dependencies on the framework, you can easily reuse them in other applications without using the Spring framework. POJO makes Java Spring non-intrusive.
Spring is the framework of choice to wire enterprise Java applications. It has solved a number of problems that enterprise Java applications has faced since the complicated associated with EJB2. A few of them are here. Firstly, Spring takes loss coupling between classes by dependency injection. While loss coupling is beneficial to application maintainability in the long run, the first benefits are realized with the testability that brings in. If objects are widely using Spring, writing unit tests becomes easier. We can easily sub or merge dependency and write them into objects. For the second one, programmer has to perform a Java naming and directory interface lookup, get a connection and populate the results before. It resulted in duplicate code. One of those problems Spring solved was by cleaning up old plumbing code. With Spring JDBC, Spring JMS, and other abstractions, the developer could focus on writing business logic. And then, using EJBs makes applications complex, and not all applications needed complexity. So Spring provided a simplified, lightweight way of developing applications. If the distribution was needed, it can be added later. In spite of its ever-looming presence, Spring did not restrict the flexibility or choice of the frameworks that application architects or developers had. For example, Spring's framework provided great flexibility in the web layer. We have the choice of integrating with a wide range of view and template frameworks. When Spring Framework is used to manage beans, the Spring IOC container manages the lifecycle, creation, use, auto-reviving, and extraction of the beans. It makes it easier to weave addiction functionality around the beans. Spring encourages the use of a number of disciplines by default. A few examples are as follows. 1. Dependency injection or inversion of controller. This is the fundamental discipline Spring Framework is to build to enable. This enables loss coupling and testability. Second one, singleton. All Spring beans are singletons by default. 3. Factory pendant. Using the bean factory to instantiate beans is a good example of the factory pendant. 4. Front controller. Spring MVC use the dispatch service as front controller. 5. Template methods helps us to avoid boilerplate code. Many Spring-based classes, JDBC template and JMS template, are implementation of this pattern.
That brings us to the end of the presentation. I would like to summarize by saying Spring provides better leverage with each line of the code right than where you know, and you can handle each line which is faster and requires less maintenance. Nowadays, it's lightweight, text-rest, easy to develop, and easy to test the features that make Spring widely used. Simply put, using Spring is to make life easier for Java web development. Thank you so much for your interest and attention.
Hi everyone, we're group 11. Today we will talk about Pyramid. Here is our outline. Pyramid is a Python open source web application framework based on Web Server Gateway Interface. It's a part of Pylon Project, an organization that develops a set of web application technologies written in Python. It supports Python 2 and Python 3. Its slogan is Start small, finish big, stay finished. Pyramid is designed to make it easy to write web applications. Pyramid follows the design and engineering principles. Simplicity. Pyramid is designed to be easy to use. So you can get started even if you don't understand it at all. And when you're ready to do more, Pyramid will be there for you. Minimalism. Out of the box, Pyramid provides only the core tools needed for nearly all web application. Mapping URL to code, security, serving static assets, file like JavaScript and CSS. Additional tools provide templating, database integration, and more. With Pyramid, you can pay only for what you eat. Documentation. Pyramid is committed to comprehensive and up-to-date documentation. Pyramid is designed to be noticeably fast. Reliability. Pyramid is developed conservatively and tested exhaustively. Our motto is, if it's untested, it broke. Openness. With Pyramid, the Pyramid software is distributed under permissive open source license. So why we choose Pyramid? First, Pyramid is modern. Pyramid is fully compatible with Python 3. If you develop a Pyramid application today, you can rest assured that you will be able to use the most modern features as a favorite language. And in the years to come, you will continue to be working on a framework that is up-to-date and forward-looking. Second, Pyramid is tested. Untested code is broken by design. The Pyramid community had a strong testing culture and the framework reflects that. Every release of Pyramid has 100% statement coverage and 95% decision condition coverage. It's autonomically tested using Travis and Jenkins on supported versions of Python after it commits to its GitHub repository After pyramid add-ons are held to a similar testing standard. Pyramid is documented. The pyramid documentation is comprehensive and friendly to newcomers. The development team also maintains the pyramid community cookbook of recipes demonstrating common scenarios you might find. Also, users can contribute to documentation as well as official tutorials. You can get help quickly with pyramid. It's the goal is that no pyramid question go unanswered. Whether you add a question on IRC or the Python Discord mailing list or on Stack Overflow, you are likely to get a reasonably prompt response. Pyramid is also a welcoming, friendly space for newcomers. Now, we will use Pyramid to build a Hello World application. So first, line 6 to 8, we implement the view code that generates the response. From line 12 to 14, we use Pyramid configurator in the context manager to connect view code to a particular URL role. Line 15 to 16, we publish a web server gateway interface application using an HTTP server. Now we try to run the application. Note that we need to create a virtual environment for all Python application. Also, we need to install all dependencies that the application needed. The application will be available on port 6543. And here is what we're waiting for.
Authentication and authorization in Pyramid is done with the help of a built-in optional security model. First, we provide a security policy where we have hashing for good security, as well as the relevant check password functionality, and a remember function to generate a cookie for the session. There is a forbidden view configuration so that the user gets redirected to login instead of being able to allow just anyone to see what they should not. Let's have a look at our website. As you can see here, if we try to visit the Hello page, we would find that we lack the permission to access it. So let's log in. And you'll see that we are where we want to be. In fact, changing the URL, we can still go back to the home view, go back to Hello. However, if we log out, visiting Hello will require us to log in once again.
So every reasonable backend server should be able to handle HTTP requests and response. How does Pyramid allow this? Pyramid, like other Python web applications, follows Whiskey. It has its own implementation of request and response, which are extended from the WebAll package, which is a wrapper around the Whiskey environment. Thus, Pyramid is able to communicate with other Whiskey apps. What does Pyramid request and response have to offer? Pyramid request inherits some common attributes from the WebAll package, for example, request method, get, post, params, etc. Additionally, Pyramid request has extra attributes which further facilitate the Pyramid workflow with views and templating system. For example, each request has to be passed into a view. Therefore, a request has a view name. You can access a section data in request section. Request has a match date, which is a dictionary that initializes when the request URL is matched. It contains all the query string passed into the URL. Request can also generate a full URL with a view name and dynamic parameters with round URL method. Pyramid response has three fundamental attributes: stated code, a header list, which is a list of response headers by which you can modify the response headers, and app iterer, which is an iterable extracting data from the response body. Other attributes are derived from this iterable. Let's look at an example for the request. This request is passed into a wiki page edit view. It then extracts an UID query string with match date. Next, it checks if something is submitted with params and extracts the data from the submission with post items. Lastly, it generates a full URL given the wiki page view, round name, and dynamic UID parameter. How about response? Pyramid returns a response to console through a view. In this example, a request is passed into the view. It sends a response back with a string contains the request URL plus a name given by user. In case no name is given, no name provided is returned. You can instantiate the response object and pass in the content type, which is a text in this scenario, and the response body. Pyramid also support HTTP response status. The HTTP exceptions module contains classes for each kind of error response, where you can insert appropriate error bodies, for example an error message for the HTTP not found, or a new URI for the redirection. Pyramid also supports section. So what is a section? It is a period of time or continuous activity that can be used to represent a user interaction with a web application. For example, a shopping cart has a section. How to use Pyramid section? First, you have to configure a section factory with a built-in module, and then you can use section object provided by request and access it like a dictionary. Now let's take a look at a demo for section. See, here is a sample application that I implemented using Pyramid to demonstrate the use of section. This simple implementation only has one view whose name is home. The first time home is visited, it set the counter to 1 in the section, and every subsequential visits by user in the duration of the section, the counter is increased by 1. My application is running on the localhost at port 6543. As you can see, the first time this home view is visited, it set the counter to 1. And if I reload the page, it's increased the count because this is the same section. To illustrate a different section from a different user, I'm gonna open a different browser and send a same request to the URL. And as you can see here, the counter is reset to 1 because this is a different section from the one that we see before, and we can increase the counter by revisit the home view.
We have seen how a small simple Hello World application can be implemented and run in Pyramid, but web applications don't always stay small. To support the growth of a web application, Pyramid comes with the URL dispatching feature that can deal with sophisticated URL design. URL dispatch means that we can use variables as placeholders in the URL and then can extract the part of it that we want into a Python dictionary and then match to a view in the application. Here's how URL dispatch works in Pyramid. Let's say we want to send a request to this link here. And what we want is to extract the value CMPT and 470 in order to display the corresponding correct information on the page about this course. We first need to add a new route to tell the application that this URL with the pattern /courses/course abbreviation/course code matches to a view in the application. Here, course abbreviation and course code are placeholder variables that will be used in matching. We then define a view, telling it what information it needs, which in this case is the value CMPT and 470. Using the function matchDict, these values are extracted into a Python dictionary. In this example, the URL with this pattern will generate this dictionary after matchDict. URL dispatch is very useful since it's easy to get a desired value from the URL anywhere in the application that has access to the request. It helps reduce the necessity of passing data around through functions parameters, and this comes very handy when the application grows bigger and the URL is longer and more complex. Let's look at a quick demo that shows how helpful Pyramid is in handling longer URLs. Here I have an application that allows its users to write posts about awesome and interesting stuff, I assume, and other users can leave comments under each post. The list of all posts can be requested via this URL. Clicking on a post will show the post and all the comments left on it. And clicking on a comment will show the comment's details. This long URL is used to request this webpage of comment. On the page, the information such as the post ID and the comment ID is extracted from the URL using matchstick in the code. I don't have to pass the post ID and a bunch of other information through functions parameters. If anything, Pyramid URL dispatch makes my code cleaner, unclustered, and more simple to write and to read.
The Pyramid community strongly supports the SQL Alchemy project and its object relational mapper as a convenient Pythonic way to interface to databases. With that, we can use an SQL database to store, list, add, view, and edit pages by using SQL Alchemy models. This is how to add it to a Pyramid website. First, we add the following models to the list of the required Python modules in setup.py. We can also make a Python script to initialize the database and register it as a console script in setup.py. Then we provide the location of the SQLite database to development.ini. In init.py, we need to configure the database engine and other configurations needed to run the database correctly. Lastly, we can create a model in the model section that represents our interface to the database and use it in our views and any other place to query, add, and remove elements from the database. Debugging in Pyramid. There are two main methods of debugging, either through the built-in debug toolbar or the terminal. I'm going to demo both, but first this is how to add the debug toolbar to a Pyramid website. We add the debug toolbar module to the list of required Python modules in setup.py, and then we tell development.ini to include the debug toolbar. The debug toolbar is accessible from this red icon on the right side of the screen. The debugger gives us information about the various HTTP requests. For each request, we can view the HTTP headers for both the request and the response. We can also get information about the performance, which is useful for developers to see what exactly is using up the resources. And also, I personally like the SQL Alchemy tab because it makes the communication between the web application and the database much clearer. So now I'm just going to comment out one line. We should break things in the web application. And if we go back to our tab, we can see that we get the traceback information that should help us debug the issue. And we also get the same information on the terminal. And here you go, these are the two ways to debug the Pyramid web application.
Just as with any other framework, Pyramid comes with its own set of benefits and drawbacks. It's a micro framework, which is great, since developers can be very flexible with what they have at their disposal. And there isn't that much documentation that they're going to have to deal with. It also has support for many external plugins, and on its own can deal with important matters like debugging with a debugging tool explored earlier, and auto-escaping with the help of Jinja bindings to prevent cross-site scripting. What's not so great though is that because it's a micro framework, developers are going to need to find more tools to supplement what is lacking. And it's harder to start since you'll be quite limited at the very beginning of the development process. There also aren't a whole lot of people that use it, and it's hard to find many people who can actually help with this. There are barely any, say, YouTube tutorials out there on the topic to help you. All in all, choosing Pyramid over Django, which is a framework that has a lot more in one, is kind of like when choosing to use Arch Linux over Ubuntu.
Pyramid is proud to be a framework that can start small, finish big, and stay finished. This is actually Pyramid's slogan on its official documentation website. You can start with a small single file module without feeling overwhelmed to set up everything complex in the beginning, which might also be an overhead if your application remains simple that does not use those complex features. However, Pyramid is still flexible enough to let you decide how you want to use the database, templating, and security later. If you become more ambitious and ever decide to grow bigger, Pyramid has built-in extensions facilities that can scale with you, but at the same time still ensures that you don't lose all the performance and quality features that you have already spent hours on. This means that you don't have to change to another framework to fulfill your ambition. because Pyramid got you covered and can help your application stay finished. In addition, Pyramid is well tested and its documentation is really well written. And in fact, one of our team members said that going over the Pyramid's quick tutorials on the documentation page feels as if he is reading through a nice story. To wrap up our presentation, here's a fun fact about Pyramid should you need something interesting to include in the tech evaluation summaries to prove that you watched our presentation. Pyramid's official documentation website is actually not responsive enough and not mobile friendly. So if you are like me, opening up the Pyramid's documentation page on your phone's browser while waiting in a very long queue for the self-checkout service when grocery shopping, and hoping to kill your time by reading the Pyramid's documentation, you're not going to have a good experience. And that's all about Pyramid. Thank you for staying until the end.
GraphQL is a query language, originally developed internally by Facebook in 2012, and it is used to communicate between the client, the browser, and the server. It allows you to ask for specific kinds of data, ask for exactly what you want, and get back exactly what you asked for. In essence, all GraphQL is a specific way to use tools that we already have to read and mutate data in APIs. GraphQL is a specification built around HTTP for how you get and receive resources from a server. Instead of using REST and incorporating multiple endpoints when you interact with the server, GraphQL gets rid of the entire idea of having multiple endpoints and gives you just one endpoint to deal with. And the way that you determine what you get from an endpoint is determined based on the query that you send to that endpoint, instead of what endpoint you send the specific data to. For the backend developer, GraphQL provides a type system that allows you to describe schema for your data. As a result, the front-end consumers of the API are able to request and explore the data that they need. As mentioned previously, GraphQL offers only a single entry data point. By describing its return shape in JSON, data can be queried by the front end, and the back-end developers then write code in order to resolve that request. The main goal of GraphQL is to make queries smarter. What do I mean by that? Well, GraphQL aims to prevent the overfetching and underfetching that is commonly experienced with the RESTful approach. Sometimes data may not be complete, and you have to make another query, and sometimes there's too much data as a result of a query that you don't use nearly all the data for, and as a result of not optimizing the resource sufficiently. This is a massive issue, and when you're dealing with a large scale of data, like for instance, Facebook, where you have billions of people querying the data daily, this becomes a real problem. So, how does GraphQL work to tackle this? First, you can create a custom object to construct a schema using the type keyword. Type is able to have multiple fields, like for example, the type student might have student ID, name as a string value, and GPA as an int. In addition, every GraphQL API has a query type, which is the main entry point of the API for the consumer. Now, from the query side, we can query for a specific student's name or ID. You may also want to mutate the data, in which case you could go simply type mutation and define exactly how the data can be modified on the API. Then we can resolve this code in any programming language.
Let's take a look at some of the features specific to GraphQL. First, GraphQL allows flexible and efficient data fetching. With GraphQL, the user can request specific data in the database with a single query. The user defines the request object on the client side instead of the server. This means that the query retrieves only the data specified by the user, and there is no overfetching or underfetching. The user has the ability to control the type and amount of data needed. This way, multiple resources requests can be made in a single query call, which significantly reduces the number of network round trips to the server and saves a lot of time and bandwidth. Another way GraphQL saves time would be in that it auto-generates the API documentation. Once a field, type, or query gets updated, these changes are automatically reflected on the documentation as well. Also, in GraphQL, versioning is not required because the resource URL is the same across the entire application. By using a single evolving version of API, GraphQL allows continuous access to new features and encourages cleaner and easier to maintain server code. This characteristic of GraphQL allows for rapid product iterations as well. The single API endpoint allows users to access multiple resources, and any changes on the UI or the front end does not have an impact on the backend server. In addition, GraphQL provides insightful analytics feature through the use of resolver functions, which collect data requested by the server. All of these features are made possible through the use of schema definition language. GraphQL uses a strong type system to define the capabilities of an API. This system is called the Schema Definition Language, or SDL. The SDL is the syntax for writing schemas that describe kinds of objects that can be queried on the server and the fields these objects have. The schema defines what queries can be made, what types of data can be fetched, and the relationships between these types. These relationships between data can be represented in graphs, hence the name GraphQL. Based on the graph data modeling with the schema at its core, GraphQL offers three primary operations. 1. Query for reading data, or the retrieval of existing data. 2. Mutation for writing data, or updating data. And 3. Subscription for automatically receiving real-time data. Then, let's take a look at some code in real life.
Now I'm going to show you some example GraphQL queries. We're using PostGraphQL, which is an excellent project for creating a GraphQL server from a Postgres database. I'll start by quickly showing you our database schema. So our application is dealing with movies and TV shows. We basically have a number of shows here in the show table. Each show has a number of actors. Shows can also have reviews, and we also have the characters in each show. So now after spinning up our GraphQL server with PostGraphQL, here's what we can do. This is the GraphQL IDE, which is a great tool for testing things out during development. Here's a basic query that gives us all of the shows, and for each show we get the title, release date, and synopsis fields. And then we get the result on the right side here. So we just say all shows list, and then we say which fields we want, which is title, release date, synopsis. And we can optionally add a name to this query, like this. And we get the same result. Next, let's get the shows and all the actors and characters for each show. So here we do all shows list, and then we get information from the show again, like before, title, release date, synopsis. And then we get the show actors by show ID for each show. And then from the show actors, we get the character name, the actor first name, and actor last name. And then when we run that, we see we get a list here, and then we get characters and actors. Next, let's get a specific show by its ID. So here we get the show with ID 1. We just pass in ID 1 here. We run that, and we get the result. Now let's try to get multiple shows based on their ID. So here we want the show for ID 1 and the show for ID 2. Here we have to add an alias for each show because otherwise they'd both be called show by ID and they'd conflict. Here we can see the result from the last query, show by ID, and we can't have two with the same name. So we use an alias here. We call the first one show1, second one show2. We run that and we can see in the result, we get show1 and show2. And then we have some repeated information here. As you can see, this is the same as this. So we can use a feature called fragments to avoid repeating ourselves. So here we create the fragment and we call it show name. And then within the fragment, we have title, release date, synopsis, and we can pass in the fragment with this syntax here. And we run that and get the same result. Now let's take a look at mutations. So this is for creating, deleting, and updating resources. Let's start by creating a show review. So here, we pass in the information for the show review we want to create. In input, so we're creating a show review, and then our review is we like the show a lot, rating 5, show ID, which indicates which show we're reviewing, is 2. And then in a mutation, you can also ask for information back. So this gives us the show review that we just created. And then for that show review, we want the show from the show ID, and then the release date and the title. So this basically says we want the release date and the title of the show that we just reviewed. Now let's try something a bit more complicated. Here we'll update the name of a series, delete a show review, and create another show review. Now this is great because we can do all of this within one request. So here we update the series name, and we want to change the name of the series from SpongeBob to SpongeBob SquarePants. And then we get back the name of the series and the ID, and then we want to delete the show review with ID 1 and just get back that review. And we also want to create a show review like what we just did. And then there we go. Those are some example queries.
Next we talk about integrating GraphQL with projects. GraphQL is flexible with many languages and frameworks, and we can find different support for the languages we are using in the GraphQL support page. GraphQL acts as a middleman between the client and the database, where we tell GraphQL about the shape of the data we want, and GraphQL will handle retrieving the data. HTTP is a common method for web applications to communicate with GraphQL server, which means that as long as our project is capable of making HTTP requests, there is a way to integrate GraphQL. In the developing stage, GraphIQL provides an interactive environment where we can test out our query itself and not worry about other frameworks or code around it. In the production stage, tools such as Apollo Studio can also be set up to monitor the flow of our data and who or what is making queries to our data graph. Here is an example integration we have for our project, where we use Docker to start up 3 containers. One for the front end, one for GraphQL, and one for the database itself. We communicate with the GraphQL server from the front end using HTTP requests over the Docker network bridge, and GraphQL handles retrieving the data. Traditionally, multiple REST API calls would have to be used between the client and the database to retrieve the data we want, and further shaping it into useful responses for consumption. The beauty of GraphQL and what makes it useful is that we no longer need to do this, and can directly ask GraphQL for the shape of the data we prefer. As mentioned in earlier slides, this not only reduces the round trip time, but also reduces engineering complexity overall. It is worthy to mention that the integration does not depend on the front-end framework we use. React.js frontend can really be substituted with any framework we like, and this would still work. Again, because all we really need is to make HTTP requests. In this particular example, we can also have other containers communicating with the GraphQL container using the Docker network bridge if we really need to.
GraphQL can reduce the number of back-to-back API calls. Each query generated by the client asks for all of the data it wants. This reduces the number of round trips required. The server responds with only data client wants. This reduces bandwidth requirements. This is especially important for mobile devices with slower or limited networks. GraphQL is supported in many programming languages as both server and client. This makes transitioning or starting a new project to use GraphQL easier. GraphQL can retrieve data from multiple data stores. Data stores includes different databases and third-party APIs. This is useful when data is distributed. Field deprecation can be specified at field level with a deprecated directive. This removes the need to put deprecation notices at multiple API endpoints. You only need to place the directive at one location, the schema. GraphQL is not all or nothing. GraphQL can coexist with a conventional REST API. This means existing projects with a REST API can integrate GraphQL and leverage the best of both worlds. The popularity and exposure of GraphQL has been steadily increasing since the public release in 2015. As with all things, there are pros and cons. We shall look at them on the next slide. API versioning is discouraged in GraphQL. What is encouraged is evolution of API. Evolution is putting up a deprecation warning on a field, then later removing the field. When to remove the field is not clear. This step should be done when all clients no longer use the deprecated field. However, it is unlikely that all clients will be updated every time a field is deprecated. The clients will then break when the field is removed. GraphQL is not as mature as alternatives. The rapid development may make it more likely to introduce bugs. The best practices for GraphQL usage or implementation may change over time. Many GraphQL servers serialize responses with JSON, but this is not required by the GraphQL specification. This may change to YAML or other formats. Caching is currently more difficult in GraphQL than REST APIs. In REST, GET request responses can usually be cached by the client browser with URL as the cache key. In GraphQL, all queries use the same endpoint. This is more akin to POST requests in a REST API, even if GraphQL queries are cached. We would need to identify which queries change the state of the data store. For example, deleting or mutating a record. These queries should not be cached. Errors may be more difficult to handle client-side for GraphQL responses. All errors are returned in an errors entry as a list. The severity of the error is usually not indicated. Errors may include a malformed query or unable to access the data store by the GraphQL server. The GraphQL server usually returns HTTP 200 OK as the status code, even if there is one of the aforementioned errors. The status is not 200 OK only if the error is on the HTTP transport level.